They weighed 90,000 pounds. They ran on raw diesel and operator nerve, no sensors, no software, no mercy. These were logging machines so brutally overbuilt that some are still running today, long after the factories that made them shut down. The engineers behind them weren't chasing fuel efficiency ratings or warranty claims. They were chasing indestructibility. They found it. Here are the machines that proved iron always wins. Number 1. The Caterpillar D8H bulldozer. We start with one of the most legendary pieces of iron ever built, the Caterpillar D8H. Produced from 1958 to 1974, this machine is still running on logging sites, farms, and construction projects around the world today, over 60 years after it rolled off the assembly line. That alone tells you everything you need to know about how it was built. The D8H was powered by a Caterpillar D342 diesel engine, a naturally aspirated 6-cylinder inline powerhouse. In its original configuration, it put out 235 horsepower after Caterpillar turbo-tuned it early in production. Its operating weight ranged from 80,000 to 90,000 pounds depending on configuration. That's 40 to 45 tons of steel and diesel. Starting a D8H was a ritual in itself. The machine used an old-school pony motor system, a small 2-cylinder gasoline engine that had to be started first with an electric motor. Once that small engine was running, it preheated the diesel's coolant and intake air, then cranked the massive main engine until it fired. On a cold morning, that sequence could take real patience and more than a few hammer taps. In logging, the D8H was used for everything: building roads into virgin timber, pushing slash, clearing brush, and dozing massive log decks. The Caterpillar D8 family had already proved itself globally. During World War II, thousands of D8 series machines were supplied to the U.S. Armed Forces, and after the war, the civilian market couldn't get enough of them. Over 23,500 examples of the D8 2U series alone were delivered before the D8H replaced it. Here's what modern machines can't match. The D8H's mechanical simplicity meant it could be rebuilt in the field with basic tools. No diagnostic computers required, no proprietary software. Loggers in remote Canadian and Pacific Northwest camps could pull the engine, rebuild the undercarriage, and have the machine running again without ever calling a factory technician. Truckers driving past D8Hs at work would honk in salute. That's how respected this machine was. Many are still running today, and parts are still available because the design never really changed in its fundamentals. That kind of longevity is simply not built into modern machines. Number 2. The twin D8 Peterson Cats CMC dozer. If one D8 was legendary, what do you get when you bolt two of them together? You get the twin D8, one of the most audacious engineering solutions in the history of logging, and arguably the most powerful wheeled or tracked land machine of its era. In the late 1940s, Buster Peterson, working at Peterson Tractor and Equipment Company in San Leandro, California, drew up designs for something unprecedented. He took two Caterpillar D8 tractors and joined them side by side behind a single enormous dozer blade. The result was a machine that produced 269 drawbar horsepower and delivered twice the working power of a single D8. It had a 15-ton ripper on the back. Some configurations used blades between 16 and 21 feet wide. The first recorded twin D8 was delivered in 1950 to Morrison Knudson's Farmington Dam project in Stockton, California. Another went to the Hungry Horse Dam project in Montana that same year. A particularly famous high-clearance version was delivered in 1951 to the King Ranch in Texas, specifically built for land clearing, with elevated clearance to push through thick brush and timber. Buster Peterson obtained a patent for the twin D8 in 1954. That was the exact same year Caterpillar launched its own 286 horsepower D9, making the twin D8 obsolete almost immediately after it was patented. None of the original twin D8s survived, but the machine was so legendary that in 2013, a recreation was built by Peterson cat collectors Ed Aiken and Glenn Gilotti. That restoration is now on display at the Antique Caterpillar Machinery Museum in Salem, Oregon. What modern equipment can't beat: the pure, unrestricted brute force approach of combining two complete machines into one. Today's engineering philosophy is about computerized precision and fuel efficiency. The twin D8 was about one thing only: maximum force. No modern manufacturer would build something like it, because regulations, emission standards, and market economics make it impossible. It was a product of an era when the answer to "we need more power" was simply weld two machines together. Number 3. The Timberjack 200 series skidder. Before rubber-tired skidders existed, moving logs out of the forest meant bulldozers, horse teams, or hand labor. Timberjack changed all of that, and the Model 200 was the machine that started the revolution. Timberjack was founded in Woodstock, Ontario, Canada in the 1950s by Wes McGill and Robert Simmons. Their breakthrough came in 1962 with the Model 200, the first articulated four-wheel drive skidder ever built. It was powered by a Ford gasoline engine producing approximately 60 horsepower and had a suggested list price of $8,925. The articulated frame design, which divided the machine into a front and rear half connected through a central pivot point, was a genuine engineering first for the forestry industry. Timberjack had to secure patents on the design immediately to protect the innovation. What the articulated frame gave you was something no previous logging machine had: tight maneuvering capability in dense forest, combined with four-wheel drive traction across the roughest terrain. The front and rear axles were both stationary and fixed, making them far more rugged than conventional tractor front axles. The machine could get into places bulldozers couldn't navigate and pull out loads that horses couldn't move. The impact of the Timberjack 200 on the logging industry was enormous. One machine with a single operator could outperform the equivalent of 4 traditional logging crews. The industry recognized it immediately, and within years of the Model 200's introduction, rubber-tired skidders appeared from dozens of companies. Athey, Pettibone, Franklin, Can-Car, International, Cat, Clark, and John Deere all rushed to produce competing machines. Timberjack's design became the template for the entire market. By the late 1990s, Timberjack had become the world's largest producer of forest harvesting equipment, with machines deployed in over 80 countries. John Deere purchased the company in 2000 for a reported acquisition that also included Warata. The Timberjack brand was eventually phased out in June 2006 at the Forestry Fair in Florence, but the articulated skidder design it pioneered remains the industry standard today. No modern improvement has fundamentally changed the concept Wes McGill and Robert Simmons locked in with the Model 200 in 1962. Number 4. The John Deere 440 cable skidder. If Timberjack invented the rubber-tired skidder, John Deere redefined what it meant to operate one, with a machine that introduced something the logging industry had almost never considered before. Before 1965, wheeled skidders were, in the words of John Deere's own historical records, little more than an engine in a frame. Operators sat exposed to the elements, the noise, the vibration, and the very real danger of falling logs and snapping cables. The John Deere 440 cable skidder, released in 1965, changed that formula entirely. The 44 housed 59 horsepower and introduced the concept of an operator station designed specifically around safety and productivity. It came equipped with features that previous skidders didn't offer: ergonomic controls, protective canopy, and a purpose-built cab environment that reduced fatigue during long shifts in the forest. It was the precursor to the fully enclosed cab machines that followed. John Deere even introduced the 4040 crawler with an easy-to-operate inside-mounted hydraulic blade as a direct companion machine. The 440 was part of a broader John Deere push into forestry that had started with the MC crawler, a machine that earned high marks from loggers specifically for its performance in tough terrain like steep slopes and soft soil. The MC and 440 together established John Deere's reputation in logging that would carry the brand through the following 5 decades. In 1973, John Deere followed up with the 740 skidder, the largest in their family at the time, built with 145 horsepower, blade and winch options, and a best-in-class grapple. And in 1977, they launched the 743 tree harvester, which combined rubber tire speed with a hydraulic boom and allowed operators to harvest 2 complete trees per minute. That machine directly paved the way for today's modern harvesters. What the 440 gave the industry that modern machines have lost: simplicity combined with durability. A 59 horsepower machine with basic mechanicals that any trained mechanic could service. Today's skidders weigh 25 tons, list for $400,000, and require specialized software to diagnose. The 440 could be fixed in the woods with a wrench set. Number 5. The Stihl 07S and 08S chainsaw. Before we go further into the big iron, we have to talk about the tool that made all of it possible, the professional chainsaw. And in the 1950s through 1970s, no chainsaw defined professional logging more completely than Stihl's workhorses. Andreas Stihl invented the first electric chainsaw in 1926 and the first gasoline-powered chainsaw in 1929. But it was in the late 1950s that Stihl produced the machines that became the industry standard for professional loggers worldwide. The Stihl 07S and 08S were single-operator chainsaws, a critical development because earlier models required 2 men to operate. The shift to one-man operation doubled the productivity of every felling crew instantly. The Stihl 08S, introduced in 1959, weighed approximately 12 kilograms, about 26 pounds, and was powered by a 2-stroke gasoline engine. For the time, this was considered a relatively manageable weight for a professional tool. It could cut through old-growth timber that would have required hours of cross-cut saw work in mere minutes. By the 1950s, Stihl had already sold its 1 millionth chainsaw. By 1971, the company had 83 different chainsaw models in production, a number that illustrates just how rapidly the logging, forestry, and tree surgery markets were demanding specialized tools for different conditions and tree sizes. Stihl's dedication to direct sales through specialist dealers, a model the company still maintains today, meant that loggers could get service, parts, and trained advice rather than buying from general hardware stores. What no modern chainsaw can replicate about the Stihl machines of the 1960s and 1970s is their mechanical rebuildability. The carburetors were simple, the ignition systems were basic, and a logger with a set of hand tools could overhaul one in the field. Today's professional chainsaws are more powerful, lighter, and cleaner, but they're also increasingly dependent on electronics that can't be repaired without specialized equipment. The old Stihl workhorses ran in conditions that would kill modern electronics, repaired with tools that fit in a coat pocket. Number 6. The Prentice Hydraulic Knuckleboom Loader. Loading logs onto trucks by hand was backbreaking, dangerous, and slow. The hydraulic knuckleboom loader eliminated all 3 problems in one design, and the Prentice brand was at the center of this revolution. Leo Heikkinen introduced the industry's first hydraulic knuckleboom loader under the Prentice name, transforming the log landing from one of the most dangerous and labor-intensive stages of logging into one of the most efficient. The knuckleboom design, a multi-jointed hydraulic arm that could articulate at multiple points like a human arm, gave a single operator the ability to precisely grip, lift, and place enormous logs onto truck beds, into log decks, or onto sorting yards, with accuracy that no crane or cable system could match. Before hydraulic loaders, logs were loaded using jammers, A-frame cable systems powered by a vehicle or horse that required multiple workers and careful coordination to avoid fatalities. A log rolling off a cable load killed men regularly. The knuckleboom loader put the log under precise hydraulic control from a protected operator cab, and it could work continuously for an entire shift without the physical exhaustion that defined jammer crews. The Prentice brand became so dominant that its name became almost generic in the loader market. Multiple brands followed, including Morbark, Lemco, Timberjack, Rami, Peerless, and Timber King, all of them building their own versions of the knuckleboom concept that Prentice had pioneered. Eventually, Prentice was acquired by Blount, and the popular Prentice 490 remained in production long after. Caterpillar later acquired Blount's forestry equipment line in 2007. The 1960s-era Prentice loaders were remarkable for their mechanical directness. Every movement of the boom was a direct hydraulic action, with no computer mediation between the operator's hand on the lever and the cylinder's movement. Today's knuckleboom loaders have electronic flow control, load-sensing hydraulics, and operator assistance systems. They're more precise, but the skill ceiling of an experienced operator on an old Prentice was extraordinary. Those men could place a 30-foot log onto a truck bed with inch-level accuracy using pure hydraulic feel. No computer can fully replicate that tactile mastery. Number 7. The Pika model. 75. Every modern harvester, every machine that can fell a tree, delimit, measure it, and cut it to precise length in under 30 seconds, traces its direct lineage to a single machine built in Finland in 1973. This is where that story begins. The Pika Model 75 was designed by Finnish systems engineer Sakari Pinomäki and his company, Pika Forest Machines. Introduced in 1973, it was the world's first fully mobile timber harvester, a self-propelled machine that could fell, delimb, and process trees on site rather than requiring separate machines for each function. This was the concept that would eventually become the multi-million-dollar harvester market of today. Before Pika, a crude forerunner existed. An American company called the Mammoth Tree Shears had produced a tracked machine capable of shearing trees with trunks up to 30 inches in diameter. But it was a single-function shear, not a full processor. Pinomäki's Pika Model 75 was the first true multi-function mobile processor. The Pika came out of the Scandinavian logging culture, which was already demanding more mechanization due to rising labor costs and a forestry philosophy centered on cut-to-length processing, cutting trees to specific log lengths in the forest, rather than extracting whole trees and processing them at the mill. This approach would become the dominant logging method across northern Europe, and eventually spread to North America, South America, and Australasia. The first single-grip harvester head, which grips a tree with one mechanism, feeds it through, delimbs it, and cuts it to length in one continuous pass, was introduced in the early 1980s by Swedish company SP Maskiner. Building directly on the Pika concept, this head design became the template for every harvester head manufactured today. Modern harvesters routinely cut trees up to 900 millimeters, about 35 inches in diameter, mounted on vehicles weighing up to 20 metric tons, with booms reaching 10 meters. What the Pika Model 75 had that no modern machine shares. It was the first of its kind, designed by one engineer with a clear vision and no committee, no corporate compromise, and no predecessor to copy. It invented its own category. Modern harvesters are refinements of Pinomäki's idea. That idea has never been improved upon, only developed further. Number 8. The Hydro-Axe Tracked Feller Buncher. By the late 1960s, logging companies in the United States and Canada needed a machine that could fell multiple trees rapidly and gather them into piles, called bunches, for a skidder to collect. The feller buncher answered that need, and Hydro-Axe was one of the companies that defined what that machine looked like. The feller buncher combined two functions into one machine: a cutting head that could sever a tree at its base, and an accumulator that could hold multiple trees simultaneously before setting them down in a bunch. Earlier machines could only cut one tree at a time and had to set it down before moving to the next. The ability to accumulate 3, 4, or even 5 trees before bunching them transformed logging productivity. Hydro-Axe, along with companies like Coring, iEdge, Case, High-Tech, Franklin, Tree Farmer, and Timco, were among the key feller buncher manufacturers of the 1970s. In the early 1980s, Bell Equipment of South Africa joined with Moorbach to introduce the first three-wheel feller buncher to the U.S. market, known as the Moorbell. This partnership broke apart, with Bell and Moorbach each developing their own three-wheelers afterward. The tracked feller buncher was a game-changer for several reasons. It could operate on slopes that wheeled machines couldn't handle safely. Its ground pressure was distributed across a wide track, reducing soil compaction compared to wheeled alternatives, and its shear cutting heads, which used a guillotine-style blade rather than a saw, produced a clean, fast cut with no moving parts on the cutting edge, which meant extremely low maintenance for the cutting function itself. By the 1970s, the industry was seeing mechanical harvesters dramatically increase both safety and production. The shift from manual felling, where chainsaw operators worked directly under trees they were cutting, to feller buncher operation reduced the fatality rate in tree felling dramatically. The operator was now inside a protected cab, not on the ground with a chainsaw. What old-era feller bunchers had over modern machines? Raw mechanical simplicity in the cutting head. Modern feller bunchers use disc saws and complex hydraulic accumulator arms with electronic sequencing. The early shear head designs had almost no moving parts in the cutting mechanism itself. They slammed shut on a tree like a giant scissors, and that was it. Maintenance was minimal compared to saw heads, and there was nothing to electronically fail. Number 9. The Clark Ranger Articulated Skidder. The rubber-tired skidder market of the 1970s was one of the most competitive in the history of logging equipment, and Clark's Ranger line was one of the most durable and capable competitors in that brutal market. The Clark Ranger earned a reputation for toughness that is still discussed by loggers who operated them decades later. Clark Equipment Company entered the forestry market with the Ranger brand, producing articulated grapple and cable skidders that competed directly with Timberjack, John Deere, and Cat. The Clark Ranger's mechanical design prioritized repairability. The machine was built with standard, generic drivetrain components wherever possible, making it cheaper to maintain in remote logging camps far from dealer service centers. In the early 1970s, the standard rubber-tired log skidder had settled into a recognizable configuration, approximately 20,000 pounds operating weight, around 100 horsepower, and either cable winch or hydraulic grapple attachment at the rear. The Detroit diesel 3-53 engine was extremely common across the market. A two-stroke diesel that was famously loud, you can hear it coming, in the words of one veteran logger, but equally famously tough, the grapple skidder, which replaced the cable winch with a hydraulic claw that could grab a bunch of logs directly without requiring workers to attach individual choker cables, transformed log extraction productivity significantly. Late 1950s development of grapple technology had led by the 1970s to highly refined hydraulic grapples that a single operator could use to grab, lift, and drag enormous bunches of logs without anyone needing to set foot in the cutting area. The Clark Ranger brand passed through several hands, from Clark to VME, then to Valmet, then to Allied Systems, which eventually stopped skidder production entirely. But throughout its production run, the Ranger maintained a following among loggers who valued its combination of field repairability and performance in heavy conditions. In the Pacific Northwest, where Cat and John Deere eventually dominated, Clark held its niche specifically because its machines were built from parts any mechanic could source. What the Clark Ranger had over today's machines. It was built for independent loggers who needed to maintain their own equipment without a factory dealer within 200 miles. Modern skidders, with integrated electronics, proprietary hydraulic systems, and emissions control components, are simply not field maintainable in the same way. The Ranger was a machine a skilled mechanic could keep running indefinitely with standard parts and field tools. Number 10. The Washington Yarder. Our final machine is one of the most impressive pieces of logging engineering ever built, and it's still in use today in steep terrain that no other logging system can access. The cable yarder, and specifically the Washington Iron Works tower yarder, represents the pinnacle of the high lead logging system that descended directly from the steam donkey era. Washington Iron Works of Seattle. Washington was one of the primary manufacturers of cable logging equipment throughout the mid-20th century. Their yarders, massive, diesel-powered machines equipped with multiple drums of steel cable and capable of operating tower systems that could reach far into steep roadless terrain, were the backbone of Pacific Northwest old-growth logging for decades. Here's how the Washington Yarder system worked. The yarder itself was a large diesel-powered machine mounted on a trailer or on a purpose-built carrier. It had multiple cable drums, the main line, haulback, and straw line, each controlling different parts of the cable rigging system. A separate steel tower, sometimes 100 feet tall, was erected near the machine to provide the elevated lead point for the cables. In mountainous terrain where no road could be built and no skidder could work, a skilled rigging crew could set up a Washington Yarder system and extract timber from slopes of 60, 70, even 80% gradient, terrain that would flip a wheeled machine in seconds. The rigging crews who worked these systems, the choker setters, rigging slingers, and hookers, performed some of the most dangerous work in the logging industry. Choker setters worked in the area where logs were being pulled, attaching steel cable chokers around individual logs. When the signal came to the yarder operator, the main line would tighten and the log would begin moving, sometimes unpredictably, rolling over stumps, bouncing off debris, and occasionally launching into the air. A choker setter caught in the wrong place when a log moved was unlikely to survive. The Washington Yarder continued to be refined and built through the 1980s and 1990s. Tower yarders produced by Washington Iron Works, Medill, and other manufacturers remained the only practical solution for extracting timber from the steep coastal mountains of British Columbia, Washington, Oregon, and Alaska. Even today, modern tower yarders based on exactly the same principles are the only way to log those slopes. No wheeled or tracked machine has been built that can replace cable yarding on extreme terrain. What the Washington Yarder era machines had that modern ones don't: They were engineered by people who understood the physics of cable rigging in forest terrain at the most fundamental level without software assistance. Every decision about drum gear ratios, cable tensions, tower angles, and rigging geometry was made by operators and engineers who carried that knowledge in their heads, developed through years of field experience. The machines were built to be adjustable and repairable by the same people who used them. Modern yarder systems are more automated, with computer-controlled drum tension and electronic safety systems, but experienced operators will tell you the old Washington yarders were more responsive to a skilled hand on the controls than anything built since. If this video taught you something new, subscribe and hit the bell notification. We go deep into the history of the machines that built the modern world every week. Drop a comment below which machine from this era do you think deserves the most respect. I want to hear from operators who actually ran these things. Until next time, respect the iron that came before.